So last time we were in the middle of section 4.4, and the part where we had actually left off on was taking a look at taking other bases, right? On this slide we did base 2 and base 16 and turning them into our base. That's what we were looking at. And we said that the primary operation that we were using to do that was what? We did use a distributive, but what else? What's operations? Operations means addition, subtraction, multiplication, division. What primary operation were we using? Multiplication. It was multiplication. I asked you to write it. I don't know where I asked you to write it. I asked you to write it somewhere. It's multiplication. And so we're taking a look here at multiplying each of the numbers by the base values. Okay? So yes, there's addition. I agree. But the primary operation is its multiplication. Okay? So we're using multiplication. I mention it because when we go the other direction, we're going to use the opposite operation. And what's the opposite of multiplication? Division. So we're going to be using division as we take numbers in our system and put them in another system. So here's the visual picture I want you to get in your head, okay? So have you guys used crayons before? Nod your head. Yes, everybody's used crayons before. Crayons are a pretty good example of the way that base addition, not base addition, but base conversions can work. Okay, so I want you to imagine crayons, single crayons, there's a bunch of them, right? And then you have boxes of crayons that have 8 in them, they exist. And then the boxes of crayons that are the fun 64 pack, you guys know what I'm talking about, right? The one that has a sharpener in the back, everybody wanted it, it was really exciting. Okay, you got the sharpener pack, okay, so we got the 64 pack. So we're gonna imagine just those 3 sizes. I know there's lots of other sizes, there's 24 packs and there's 36 packs, and we're just gonna do those 3. Okay, everybody good so far? Okay, I'll give you one more visual picture in a second. So I want you to imagine coming in and seeing a bunch of crayons on the floor. It's a mess. And the only options you have for packaging them are those 3 options. Big old 64 packs, 8 packs, and then the leftovers. Okay, does everybody have that picture? Can you see the crayons on the floor? I can, they're in my head. Okay, so we come in, we see the packages, and we start packaging them back up. We're cleaning up a mess is what we're really doing, right? And those are the only boxes that we have. So the first thing we actually do is we fill the 64 packs, right? You're trying to get as many of them in there as possible and moved out of the way. That's going to make the biggest impact in the mess. And once all the boxes that can fill up with 64 packs, assuming you have enough of the boxes, and we'll assume you do, can fill up with the crayons, then you go to the 8 packs and you fill them up as much as possible, right? And then there's some leftovers when you're done. Okay, second picture. I want you to imagine our money system. Let's pretend that we only have pennies, nickels, and quarters. Everybody good so far? Okay? So again, you come in and there's pennies, nickels, and quarters on the floor. We'll put them on the desk this time, a little bit neater. They're on the desk right here, okay? And you're trying to count them. You do not start counting with pennies, do you? Most people don't. You usually start counting with the biggest coin that there is. So you kind of group together all the quarters, you might group together all your nickels, and you group together all your pennies. And then somebody wants to know how much you have, and you might start making some exchanges, right? You might exchange some nickels into some quarters or some pennies into some nickels. Now imagine you came in, instead of having pennies, nickels, dimes, or not dimes, don't do those. Pennies, nickels, and quarters, they're just pennies everywhere. There's a bunch of pennies, okay? And you have the ability to exchange them, but you only have the ability to exchange them into quarters or nickels, okay? This is what happens when somebody gives you money in a cash register, right? Is that you've got all this money in the cash register, and if you're trying to simplify what's there, you're either trying to break it down so you have more coins, or you're trying to increase it so that you can cash the draw at the end of the day. Okay, so you got all these pennies on the desk, okay? And what we would do first is we would try and figure out what we can exchange for a quarter, because that's the biggest bang for my buck. If I'm carrying around a bag of pennies, and I can turn 25 of them into a quarter, that's a better deal than turning 5 of them into a nickel, right? I have fewer coins that I'm gonna be carrying. So I'm going to figure out how many 25s. I can make a stack of 25 coins here. And I'm going to say, I want those 25 pennies to turn into a quarter. And we're going to do that for as many sets of 25 as we can. And when we're done, there's not going to be 25 left, or I would have turned them into a quarter. There's going to be maybe like 22 left, something like that, right? So then the next option is to put as many of them and turn them into nickels as possible. Okay? And then we have the pennies that are left over. Maybe there's 3 left over at the end. Can't turn them into quarters, can't turn them into nickels. They're just 3 left over. That's what's happening when we turn things into other bases. So in this one, we're working with base 4. So there's 11,028 whatever objects you want to use in your head laying on the floor, and you're cleaning them up. And the way that you can package them is only in powers of 4. Okay, not powers of 8, not powers of 5. Those are my examples, but powers of 4. So the first thing we need to know is we need to know what powers of 4 we have to work with. Make sense? Okay, what are the size of my boxes that I'm working with? So we are going to have the singles that are left over. Clearly that is one option. So I've got 1s. And I've got boxes that are 4s. And then I've got another box that's going to be like 4 squared. So how many is in a 4 squared box? There's 16. My next box is 4 cubed. What's 4 cubed? 64. It might be the last one you know. Then I've got 4 to the power 4. If you have a calculator, grab it. What's 4 to the power 4? What is it?
So 128.
It's not 128, it's bigger. 256 is what you get. Okay, that's where I stopped knowing them. So we're going to go 4 to the 5th now. So what is 4 to the 5th? Yep, 1024. We have 4 to the 6th. So what is 4 to the 6th? 4096. And I'll do one over here in this sort of margin area. There's a 4 to the 7th would be next. What is 4 to the power of 7?
28,672.
How many?
28,672.
Okay. I think that's too big. Try that again. It's like I have a smaller number than that written down. What do we have? What'd you get, Jeremiah?
I didn't get it. I was just asking what
4 to the 7th. There we go. 16,384. Truthfully, though, Neely, it doesn't really matter. It's too big, right? Whether it was 28,000 or 16,000, it's bigger than the number I have. Everybody good? So while I've written it down, this one won't be needed. Okay? So I need to start with the biggest value that works. And this is going to look familiar. We've done this before. We did it with the Babylonians and the Mayans. We're going to divide by the biggest number we have possible, which is 4096. And we're going to do it with the division algorithm. Does that look familiar? I hope so. So you're going to use your calculator and you're going to divide 11,028 divided by 4,096, and I need to know the whole number part. All right, how many whole boxes of 4,096? What object do you guys want to use? I used crayons and I used coins. Somebody find another object for me.
Highlighters.
What's that?
Highlighters.
Highlighters. Okay, we got highlighters. Wow, we've got 11,000 highlighters in our room. That's very exciting. Hope there are lots of colors of them. Okay, so we have 11,000 highlighters, and we're putting them in boxes, as many as we can in boxes that are big enough to hold 4,096 of them. How many boxes do we get filled? 2. Okay, cool. So there's 2 boxes filled. How many are in those 2 boxes? Well, that's the same thing as saying, well, I've got 4096 twice. Okay, so 4096 times 2. That's how many highlighters I no longer have spread around the floor. How many is that? 8,192. That's right. And then we're going to subtract, because this is what's going to remain that still needs to be boxed up. So when I do that, let's see, where am I over here? I think I have 2836 is what I've written down. Is that right? Cool. Now the next box is of size 1024. I'm just going down the list. Okay, I took care of the 4096. Now I'm doing 1024. How many boxes that have 1024 highlighters in it can I fill? 2. And what is 2 times 1024? 2,048. Fantastic. And then we subtract, and we can figure out how many highlighters we still have left. What do you have? 788 is what I have as well. Very good. So the next box size is what? 256. So we're going to fill in as many of 256 boxes as we can. How many can we fill in? How many? 3 this time. Yeah, we've got 3 of these. So then we take our 3 and we figure out how many we've sort of, put in boxes. 3 times my 256, and that gives me what? 768. Now, we still have boxes, whether we fill them or not, of all the sizes. So what's the next size box that I have to take into consideration? No, we got to go in order. We're going from the top, from the biggest down. 64 is my next one, okay? So I've got 64 next. This is where I am. Now I realize this is bigger. Oh, this is 20 right here, right? I realize this is bigger than the 20 I have remaining. But I need that placeholder. We've talked about how important those 0 placeholders are, right? We're going to have 0 boxes that are filled in with the 64 highlighters. So there's 0 boxes of 64, which means I'm subtracting 0, leaving me still with the same 20. Okay, so I did my, oops, got that wrong. So I did the 64. What do I do next? 1 box of 16, you bet. Leaves me with 4. What do I do next? 4. How many boxes of 4 do I get? 1. And I know that I have a 0 here, but I always have to count at the end. Again, 0 placeholders kind of thing. My last thing to divide by is what Jeremiah mentioned earlier. It's the 1. Okay, so I divide by my 1. I get 0 at the end because there's nothing left to go in those boxes. In other words, there's no highlighters that are without a box. There's no lonely ones left over. The answer is right here. And unlike when we were working with Babylonian and Mayan, there's no changing it into different symbols. This really is the answer. Just written out from left to right. David's really excited. I'm so excited for him. So we've got 2, 2, 3, 0, 1, 1, 0. It's a long number. Base what? Base 4. Now, I mentioned this before, but it's been, 5 days since we talked. Check it out. The original number is in base 10, 11,028. How many digits are there? 5 digits. I turned it into a base 4 number. How many digits do I have on my base 4 number? Is it 7? 7 digits. Smaller base, more digits. Did that happen? Yes. I turned it into a base 4 number. I have more digits that are expressed. Okay, let's try another one. I need something else besides highlighters. Legos. Okay, let's do Legos. Okay, so this one is turning it into base 9. Last time it was base 4. In order to do this, I need to know what the powers of the base are. So I've got my 1s and 9s, and then I have 9 squared. You probably know that one. What's 9 squared? 81. Fantastic. What comes after 9 squared? That is to say, what's 9 cubed?
729.
729. How about 9 to the 4th? Do you have it? What is it?
6,561.
6,561. Fantastic. 9 to the 5th. What's 9 to the 5th? It's big, right? 59,049. And I'll do my 9 to the 6th over here because I'm not going to end up needing it, but we want to always check and make sure. What's 9 to the 6th? I have 531,441. Does that match y'all's? Okay. That's too big. Why? I only have 99,999 Legos, right? I don't have 530,000 of them, right? So I will not need this one right here. I won't need to use that one, and I'll start with the 59,000. So now I've got boxes that I can stack the Legos in. They can hold either 59,049, 6561, 729, 81, 9, and then I'm going to have some left over potentially. Okay? So we're going to start by dividing by the biggest value, which is the 59,049. And we're going to divide our 99,999. And how many boxes of 59,049 can I create? 1. Okay, so I'm just going to subtract the 59,049 then. Great. Okay, so what do I get when I subtract 59,049? 40,000 what? 950. Okay, does that match? Y'all good? Okay, what am I going to divide by next? Yep, 6,561. How many boxes of 6,561 will I have? 6? Okay, so what is 6 times 6,561? 39,366. Okay, so after this, I've got typos written down, so you're guys gonna have to tell me because my values on my paper are wrong now. All right, so what happens when I subtract these? Okay, what was it over here? Avery, you have it? Say it a little bit louder.
1,584.
Okay, 1,584. Is that what you guys have too? Good. So what are we gonna divide by next? 729. So how many boxes of 729 can I get out of the 1584 Legos? Two. I think I can get two. Is it two?
Oh, yeah, it is too.
Okay, so it's 2 times 729. 1458, is that right? Okay. And then if I subtract, what's left over? I keep wanting to look at my paper, but it's wrong, so I need to stop. 126. Lovely. What's the next thing I'm going to divide by? The 81. How many boxes of 81 can I get? That one's just one. And when I subtract, what do I have? 45. What will I divide by next? 9. How many boxes of 9 can I get? I get 5, right? 5 times 9 is 45, and I don't have any more Legos to put anywhere, which means that when I divide by 1, I get 0. And I need the 0 placeholder. Okay? Then my answer would be 162,150. What's my base? 9. Check it out. How many digits did I have in base 10? 5. There were 5 9s there in base 10, right? How many digits do I have in base 9? 6. If you'd left off that 0 and you just take a second to check yourself this question, right? You'd know, whoa, I did something wrong. I shouldn't end up having the same number of digits. Correct? If you forgot that 0 on the end, it would still be 5. 5 and 5, something's wrong. Okay, the next part's the part that I was referencing when we came in about the fact that these next 3 questions I think that I have are the ones that trip people up because they're not moving into our base. They're moving from one base to another base, and none of them are 10s. Here's the thing. There's 2. Let me just tell you, first of all, I'm going to teach it to you one way that works, generally speaking, to go from any base to any base. That's what I'm going to show you. There are shortcuts if you go from bases that have similarities, like base 2 into base 8. There's going to be some questions inside of my math lab that do that. And there's a different way of doing it, and they're going to show you that. And if you like it and you want to use it, fabulous. That's great. But it's very specific because 2 and 8 are both base 2 numbers. 8 is 2 cubed. So if I look at these numbers, 5 and 7, they don't have that property, right? So the method that my math lab shows doesn't work for that. And I would rather show you a general method that works for anything. So that's what I'm going to show you, okay? So here's the deal. We're going to take whatever base we're given. We're going to go into base 10. And then we're going to go back into base 7 that we're supposed to go to. It's a 2-step process. And we know how to do both those steps. Yes, sir?
How do you know you're going from base 5 to 10?
We don't. We're going from base 5 to base 7. And I'm telling you that the way we're going to do that is to go through 10. Yeah. And the reason we're going to go through base 10 is because we already know how to do it. One of these is multiplication, one of them is division. 5 to 10. Is that one multiplication or is that one division? That one is multiplication. And 10 into base 7, that one's division. That's the ones we were just doing. So the first step's going to be multiplication steps and the second step's going to be division steps. 2-part problem. Okay, starting with 4 and 3. This is base 5. We did this last time. So when we're working with base 5, essentially we're saying is that the 4 is in the 5s place, so there are 4 5s. The 3 is in the 1s place, so there are 3 1s. So imagine having in your wallet 4 5s and 3 1s. You can picture that, right? Okay. How many dollars do you have then? Well, you have 23. Easy enough? This is now my base 10 number. It's 23. Okay?
So,
That's step 1. Yes.
I'm sorry.
You're okay.
So with the first part of the multiplication, all you're doing is you're 43, so you're assuming the 3's in the 1's place. It doesn't matter that it's in like base 5, it's still the same.
Okay, so I'm not assuming the 3's in the ones place. It is in the ones place because it's on the far right. Anything on the far right's always in the ones place.
No matter the base.
No matter what the base is, this is a 1. This is always going to be a 1.
That's
The
fine.
numbers after that are going to build on the base itself. Base, if it's base 5, we're going to have 5, and then we would have 5 squared if it was a 3-digit number, and 5 cubed, and so forth.
Thank you.
Yes. Okay? Is everybody okay with the 23? Okay, once we get to the 23, we're going to do what we were doing just a minute ago. We're going to go with division. But it's in base 7, which means I need to know the powers of 7. Well, I've got the 1's place, and then I've got the 7's place. That's cool. What's after 7? 7 squared, which is 49, and that's too many, right? I don't have 49, I have 23. So I don't even have to use a 3-digit number. It's going to be another 2-digit number. Now, that sort of destroys what I told you before, but let me clarify why it still doesn't in a second. So hold tight. So we're working with numbers now where we're doing division, but the division will start with division by 7. And we have the number 23. Okay? How many 7s are there in 23?
3.
There are 3. So 3 times 7 is 21. Gives me a remainder of 2. Divide by 1. So I've got another 2 over here. And there's 0. The answer is right here at the end. 3, 2, base 7. Okay, so this one was base 10 over here. And this one was base 5. So we started with 4, 3. And while I know the number of digits didn't change, doesn't it look like the value still got smaller? If I compare 4, 3 to 2, 3, did the number get smaller? Yeah, the individual digits, it looks like smaller numbers. Not fewer digits, because we're working with something tiny this time. The other numbers we were working with were really large. But we've got a number that looks smaller. Bigger base, smaller looking number. Moving over here into the base 7, right? Smaller base than base 10. The number looks bigger. Compare base 7 to base 5. Base 7 is a bigger base. What do you tell me about this number? 3, 2 compared to 4, 5, 4, 3? It looks smaller. Bigger base, smaller number. Okay, it always works that way. Bigger base, smaller number. Jot that down somewhere if it helps you. Let's try another one. This one's actually going to do base 2 into base 8.
I have a quick question about that last one.
Sure.
So, on the first one we did, if it was still said 0, we still counted that 0.
Mm-hmm.
But on this one, we're not. You don't count. So that one, why wouldn't that be 320?
So the goalstone is not to actually continue on with zeros. The goal is that my last step is to divide by 1. And I did that. So check it out on the last problem. So the goal is to divide by 1.
Okay, I see that.
So we know we're done when we've divided by 1. 1 and done, okay? That's what you get. When you get to 1, you're done. If you're not to 1 yet, you're not done. Okay, let's try it again. 2 to 8. So we're going from 2 into what? 2 to 10, and then 10 to 8. When we go from 2 to 10, I'm sorry, yes, Brandon.
So will we always take it to 10 if it's
The method that I'm teaching you, yes. But I'm warning you, my math lab will have a different method, and you're welcome to use it if you like it. You can click on the Help Me Solve This. They'll walk you through a different example. But I always teach it generally speaking, and this is how I do it, because it works for any base into any base. But this particular one would have another option. Okay?
yes, ma'am?
Okay, cool. First step, 2 into 10, multiply or divide. Multiply. And then 10 into 8, divide. So all of these are crazy number of numbers. There's a lot of numbers in this one, isn't there? Okay, so let's see if we can get them all written down properly. I don't even know if I have them all written on my paper right, but we're gonna try. Let's see, I've got, this would be the ones place, and then I've got 2 to the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I believe that I've got 11 numbers, so the first one is 2 to the 10th. The next one is a 1, and it's 2 to the 9th. The next one is a 0. You can include it or not include it. It's 2 to the 8th. I like to see all the powers of the 2, so I'm going to include it. I have a 1 times 2 to the 7th. Okay, I got to keep track. I've done 1, 1, 0, 1. Awesome. Now I have a 0 times 2 to the 6th. All right, I have a 1 times 2 to the 5th, and a 1 times 2 to the 4th, and a 1 times 2 to the 3rd, and a 1 times 2 squared. That's that series of 1s right there. I have a 0 times 2, or 2 to the 1st, and then the last one is 1 times 1. Or you can write it as 2 to the 0 if you want, but 2 to the 0 is 1. Okay, so your calculator will do this just fine. The very nice thing about base 2 is that when you're multiplied by 1, nothing changes, right? So let's just run through and get some values really quick. What is 2 to the 10th? Somebody tell me what you get. What? 1,024. Fantastic. Okay, so that one took care of this one. What is 2 to the 9th? Is it 512? Am I imagining that? What'd you get? Jordan, did you get 512? 2 to the 9th? Can you check it for me? 512, Mike agrees. Okay, so 512. The next one I don't need to do because it's 0 times it, so I'm going to skip that one. I'm just going to write plus 0 here. What's 2 to the 7th?
128.
128, thank you. And then the next one is 0 times it, so I'm going to write a 0 here. 2 to the 5th. Now we've got ones that I actually know. 2 to the 5th is 32. What's 2 to the 4th? 16 first. 2 cubed is 8. 2 squared? 4. That one's 4. This 0 times 2 would be 0, and then I have my 1 at the end. Okay, so grab a calculator if you haven't been doing so already. We're going to add these values all together, and we're going to get our base 10 equivalent number. So what is this when I add all this together? How many? 1,725? I have 25 written down. Is it 25? Okay. You probably have a small error. So this is base 10 number. Okay, so it went from 11 digits long to 4 digits long, right? So I've got 4 digits now. So I've got 1725. What am I going to do to turn it into base 8? I'm going to do some division. What am I going to divide by? Powers of 8, right? I need to know some of my powers of 8. So I'm going to write them here at the top. I have 1, I have 8, I have 8 squared, which is 64. What is 8 cubed? 512. And we'll do one more so you can see it's not necessary. What is 8 to the 4th? 4,096. Is that right? Okay. And I don't need that one, right? Because it's too big. So we're going to divide by 4 different values. 512, 64, 8, and 1. So I've got 512 I'm going to divide by first. That's the 1725 underneath. So how many 512s are there in 1,725? Should be 3. What is 3 times 512? 1536. Wonderful. And I subtract, I get what? It's 100 something. 189 written down. Does that look okay? Maybe?
Yes.
Yes, fantastic. Okay. How many 189s? I'm sorry. What do I divide by next from the 189? 64. So how many 64s are there in 189? 2. Okay, so I had 189. Let's subtract. What's 64 times 2? What is it? 128. And if I subtract, what do I get? 61. What will I divide by next? Divide by 8. How many 8s are there in 61? 7. More. Yeah, 7. What's 7 times 8? 56. And if I subtract, what do I have? 5. So 1's our last thing to divide by. How many 1's are there in 5? 5. So our values, they're spanning 2 little areas because I've had to carry it over. Give us 3, 2, 7, 5, base 8. Okay, there's one last problem, I believe, and this problem is putting things in order. This is not a terribly difficult question, but it does look a little bit weird if you're not really paying attention to what they're asking you. This is 4-3 base 7, 1-3-2 base 4, and then A2 base 11. You cannot make the decision based on how big the base is, and you cannot make the decision based on how many numbers are present there. We have to get these into the same way of describing it, or we won't be able to compare them. Right? If I come in speaking English and all you know is Spanish and we don't have any ground between this, we can't communicate. These numbers cannot be put in order when they're in these different, sort of like languages, right? We need to get them into something common. And so what we need to do is we need to take each of them and turn them into, what do you suppose? Base 10. We're going to turn them all into base 10 because we can do that with every single one of them. We know how to do that. And the way we turn something into base 10 is we look at their place value in the base that they're in. 4-3 is in base 7. So I have the ones place, the sevens place. I would have 7 squared and 7 cubed, but I only have 2 digits. So this is 4 times 7 plus 3 times 1. How much is that?
31.
It's 31. Yep, so this is 31. Base, what do we do, 10? I'm going to write 10 just to remind us that that's where we are now. You don't need the 10 there, but.
So, wait, so you have the 7, because the 7's base 7?
Mm-hmm.
Okay.
Yep. I did 7s because this is base 7. So Stone, by that idea, what am I going to do for the next one? When I do this one? Base 4.
So just show that.
It's base 4. So I have 1, and then I'll have 4. Okay?
All right.
And then what will come next? Well, 4 squared,
Oh,
which is 16. Okay? 4 squared. The numbers they give us are 1, 3, and 2, like that. Okay, it's powers of 4 because I'm in base 4. Powers of 7 when I'm in base 7. And in a moment I'm going to be in base 11, so I'm going to do powers of 11, maybe? Because we're in base 11? Yeah, okay. So we have 1 in the 16s place, or 4 squareds place, 3 in the 4s place, and 2 in the 1s place. So I need to multiply 1 times 16, 3 times 4, and 2 times 1, and then add them together. What do I get?
30.
30. So if I had been counting digits, 132 would have looked like it was a bigger number than 43. But it's not, because it's actually 30 in base 10. Okay? It's just like what happens when have you heard the old adage where a child gets a dollar bill and they take it to someone and they say, I want to turn my dollar bill into something more, and they turn it into 2 quarters? It's more. It's 2 instead of 1, right? And then they take their 2 quarters and they want to change it into something else and they get 3 dimes. Oh yeah. It's more because it's 3. Right? The problem is not understanding the value of the coins and the value of the bills. The value in each of these places is different. Right? Just because there's a 3-digit number does not mean it's the same value as a 3-digit number in another base. It doesn't work that way. Languages do the same thing. If you use English to describe something, you may have to use far fewer words than if you use Spanish. The languages don't match, or vice versa. Okay? Last one to do is the A2 base 11. So it's base 11, which means this one's 1. What's the next one? 11. I'm just looking at the powers. We're going to get to the letter in just a second. It's the place value, 11. And if I had a third value, what would it be? 11 squared. Okay, Lily's exactly right. Guys, got that? Powers of 11 because I'm in base 11. Now, Jonathan, you wanted me to put a 10. Did you want me to put a 10 here?
Yeah, I don't know if it's right though.
It is right, yeah. Okay, so the A value, A there, we talked about these before, right? A is 10. What's B? 11. What's C? 12, and so on, right? So if you have letters showing up, it's because we ran out of single-digit numbers for them. Yes, Lily?
Why is there a 3 on the 1 and not a 2?
Because I wrote it wrong.
Okay.
How about a 2 then? Will that work better? Thank you. I think I was just looking down at my work on the line lower, but yeah. So we had an A. A is our single digit for the number 10. Okay? So there are 10 11s, and there are 2 1s. What is that? 112. Also base 10, right? This is all base 10s. So which one? It says we're going to go from least to greatest. Which one is the least? Let's just talk about the tens numbers. Which number is the least number? Yeah, the 30 is the least one, right? So this one's the smallest. Okay, so it's like number 1 listed. Which one's going to be my number 2 number? 31. So this is my second one listed. And this one is my third one listed. But how do you think that you're supposed to input this into my math lab? Are you going to write 30, 31, 112? No, you're not. You're going to write it in the symbols that they originally gave it to you in. These ones, back here at the beginning. Well, more accurately, up here at the top. Let's change colors. 4, 3, 132, and A2. We're gonna do it in those numbers.
You don't have to write the bases.
You don't have to write base 10. If you're working in any other base, you do.
Okay, so
Yeah.
in this you would write 43 base 7.
Okay, so let's start with the smallest one. What's the smallest one?
132.
Okay, so I'm gonna write at the top because I'm out of space at the bottom. The smallest is 132 or 132 base 4. The second smallest
43 base
is 43 base 7. And then the largest is A2 base 11.
Will it tie us wrong if we just put like 132 with a number 4? Or do we have to spell it out?
Has anybody seen it on my math lab? I don't remember how it does it. If you put the number, it's not going to work, but I don't know how it works in there either. Is it multiple choice like? Is that what they do? Somebody tell me.
I think so.
I think it might be a multiple choice option, especially on this one. I bet that they're going to give you 4 different answers with different orders of numbers. That would be my expectation. But yeah, it won't let you put the base as a number. It would have it written in some way, for sure on that.
I did all that. I just didn't remember what it was.
Yeah, that's okay. Do you have a question, Jeremiah?
Sorry.
It's okay.
So we have to solve it to find the smallest to largest?
Yeah, so you have to change it into something that's comparable. So we changed them all into base 10 so that we could make the comparison. Okay? Yep.
So this last one was 11, when we divided it instead of multiplying it?
So when we're working from some other base into base 10, it's always multiplying. It has nothing to do with whether it's bigger or smaller. It has to do whether it's not base 10 or whether it is base 10. Right? It's the haves and haves not. I don't care what the other have is, right? The other piece is. It's always going to be multiplication.
Oh, yeah, I did now, thank you.
Okay?
So if you're going into the base 10, it's always multiplied, but if you're going out of base 10, that's what it's.
Correct.
Okay.
Into base 10 is always multiplication. Out of base 10 is division.